Welcome everybody. Our topic is reflection and transmission of waves. So suppose this is a wall and a string from point A to point O is attached with this wall. A wave is generated at point A by a force F. So that looks like this. At some instant, this, by some time, this becomes this, and after that the wave looks like this. So we are considering the point in this point. We are considering this point O, the particle in this point O. We can see that at every point in this string, when the wave is propagating, every points are moving in upwards. Suppose this is the point. Every particles are moving upwards, right? Not in this line, but upwards. So what happened in the point O? We can see that at point O, the particle at O will not move either in upward or in downward. So why the particle in the point O is not moving upward? Because as a reason, we can state that at the point O there is a force F, which I stated first. There is a force F from left to right at the point O, and there is also another equal and opposite force created by the wall at the same point O. Because of the presence of an equal and opposite force at O by the wall. So in this point the net force, in this point O, the net force is 0. In this point O, the net force is 0. So that is the reason why the particle at O is not moving either in upward or in downward. The particle is in static position. Now consequently the wave reflects from the point O. Firstly, when I was drawing this picture, the wave was at some point P, at some point Q, at some point Q, in this point, at this point, there is only a force in this direction, and that's why the particle is moving upward. And firstly, when I was drawing this picture, the wave was at some point P, at some point Q, at some point Q, in this point, at this point, there is only a force in this direction, and that's why the particle is moving upward. And after that, after the reflection, when the particle P have only one force that is generated in this direction, which is produced by this wall. So the wave at P, there is only a force minus F, for which the wave is inverted with respect to the original. So the wave looks like this when it is reflected from the wall. So we can see from this and this, the after reflection pi. Obviously you can see that this wave and this wave are at a phase difference of pi. Okay, the string is attached to a lightweight ring, vertical. This ring can move vertically upward and downward freely. So now what happened to the first case? Now if I made a pulse from here, from point A, the pulse will move towards the right, and at point O, like, there is force rightward for my pulse, for my giving pulse. There is a force rightward, and there is no force due to the rod. There is no force due to the rod from rightward to left. So as a consequence, we can see experimentally that the wave propagates in this way, and after some time the point O, which is attached to the ring, after some time the ring will move upward like the pulse, but we can see that it is overshooted, or simply its height is greater than the maximum of the pulse height. Its height is greater than the maximum of the pulse height from the former. And so why this happens? So why the pulse moves like these, and at the end point this moves like this, very higher. So what is the reason? As a reason, we can say that from the rightward there is also a force created, which creates a wave in the same direction. That's why the resultant wave at this point O is higher than the former. The resultant wave is higher in that former, right? Like A1 plus A1 equals to 2A vector. This case has happened here. A force is
A1 plus A1 equal to 2A1
created in this point O such that the resultant wave, this and the wave created from rightward, resultant is 2A. After reflection from this rod, the wave looks like this. This can be understand very easily. That the wave will be like this, not like this. Understand? Because the wave generated by the force from the rod is in the same direction, and that the wave will move towards this direction with a phase difference 0 degree from the former pulse. So this time the phase difference between the two pulses is 0 degree, and formerly we have got that the phase difference between the two waves was 180 degree or pi. So as we see in our first discussion, the phase difference between the incident wave and the reflected wave, when the wave is reflected from a denser medium, that was pi, or the wave when it is reflected from a denser medium suffers a phase change of pi. In our second discussion, we see that when the wave is reflected from a rarer medium, in the case it was the ring, the reflected ray suffers no phase change, or the phase difference between the incident wave and the reflected wave is 0 degree. Consider a light string attached to a heavier string. In fact, we are considering a composite string. Which is composite string means a light string attached to a heavier string, and this is the junction point. We can see this is the junction point. Okay, so in the figure A, we can see this is the lighter string and this is the heavier string. So when I made a pulse on this side, the pulse moves forward in the right side, in rightward direction, and after some time, a part of the incident wave will be transmitted through the heavier string, and the other part will be reflected from the junction point towards the forward direction in the opposite way. If a pulse is generated in the heavier string, then also the wave will propagate towards the rightward direction, and from the junction point, one part of the pulse will move towards the right way and one part will move towards the left. But the main theme is, when I made the pulse in the lighter string, then the reflected pulse is inverted to the reflected pulse is inverted from the previous pulse, from the given pulse. This pulse, you can see that this pulse and this pulse are at a phase difference of pi, for the reason I have told in the previous discussion, like our first discussion. Okay, this is first discussion. And the second case, when the pulse is created from the heavier string, then what happens? Then the reflected pulse, then the phase difference between the reflected pulse and the previous pulse, that is this and this is 0 degree. Theta equals to 0 degree here, and theta equals to 180 or pi here. That can be also understand from our discussion of second discussion. Now we can conclude that if a wave enters from rear, this is a transverse wave. This is a transverse wave. If a wave enters from a rarer to denser medium, then the reflected wave is inverted, and if it enters from denser to rarer, this is denser and to rarer. Denser to rarer, the reflected wave will not be inverted. The reflected wave, this and this, will not be inverted. This case also similar in light. As light is also a transverse wave like this, light also obeys this formula. When light is reflected by a surface backed by denser medium, there is a sudden phase change of pi between incident and reflected rays like this. But when it is reflected by a optically rarer medium, no such abrupt phase change occurs, and that is this. So we conclude that in light, this is optically rarer medium means the refractive index of the medium is lower, and optically denser means the refractive index of the medium is higher. And also we can see from these two figures that the transmitted wave from the junction, the transmitted wave has no phase change or phase difference between the transmitted wave and the incident wave is 0 degree. So we can conclude these two formulas from our discussions. Thank you.